is equal to the right hand side, then we need to find the value for a and b. So on the left hand side we are having this series, and for this series if I replace this 5 with x and ignoring the constants, then what series I get? I get x plus x squared plus x cubed up to so on x to the power n. Because we have taken x to be equal to 5, that is x is strictly greater than 1. So what is the common ratio? The common ratio is equal to second term divided by the first term, right? So this is x squared divided by x, that is equal to x, and x is greater than 1. That means the common ratio is strictly greater than 1. That is mod of r is strictly greater than 1. So for this mod r greater than 1, we write the finite sum of this GP series to be equal to the first term into the common ratio, the power n, that is the number of terms, minus 1 divided by r minus 1, where mod of r is strictly greater than 1. And if this mod of r is strictly less than 1, then we write this sum as a into 1 minus r the power n divided by 1 minus r. Right? This is for mod r strictly less than 1. Right? So here the first term is x and the common ratio is x. So for x equal to 5, we have written this result. Let's differentiate both the sides with respect to x now. So on the left hand side we get 1 plus 2x plus 3x squared up to so on. This is nx the power n minus 1 equals to, differentiating the right hand side with respect to x. So I'm having the denominator here. So this is square of the denominator. This numerator can be taken as x the power n plus 1 minus x, right? So denominator into the derivative of the numerator, that is n plus 1, x the power n minus 1, minus the numerator into the derivative of the denominator, that is 1. So this is further equal to x minus 1 into n plus 1 x the power n minus 1 minus, I can write this as x the power n into x plus x divided by the denominator. Let me take x the power n common from these two terms. So when taking x the power n common, we get, for the first term we get the product of n plus 1 and x minus 1. And from here we get minus x. And then the remaining term, that is x minus 1 multiplied with this 1, we get minus of x minus 1. And the remaining plus x divided by the denominator, that is x minus 1 whole square. Solving this bracket, we get nx minus n plus x minus 1 minus x plus 1 plus x divided by x minus 1 whole square. Cancelling these two and these two. In the bracket, let's take n common from first two terms. We get n into x minus 1 and then this negative 1. Writing x power n here, plus 1 divided by x minus 1 whole square. So on the left hand side we are having this series 1 plus 2x plus 3x square plus so on n into x the power n minus 1 equals to the right hand side. Let me multiply both the sides with x so that I can get x plus 2x square plus 3x cube up to so on n x the power n. As here I am having n into 5 the power n. So when we replace this 5 with x, so that we get this to be as n into x the power n. So on multiplying both the sides with x, I get n into x the power n. So this is equal to, multiplying x here, I get here x the power n plus 1 and here x divided by denominator. So we need to just replace now x with 5. So let's replace x with 5. We get 5 plus 2, 5 square plus 3, 5 cube, so on. So 5 can be written as 1 into 5 plus 2 into 5 square plus 3 into 5 cube, so on, n into 5 the power n equals to, if I put x equal to 5 here, I get 5 minus 1, that is 4, 4n minus 1 into 5 the power n plus 1, and here 5 plus 5 divided by, in the denominator, if I put here 5, I get 5 minus 1, 4, and 4 square is 16. So in the denominator, I am having 16. So when you match this to the original right hand side, that is this one, we get the value of a to be as n. And the value of b is 5. So this is what is required. So a is equal to n and b is equal to 5. Okay, thank you.